Yeah, so let's think back to the DRC. So I do think that was the beginning of kind of a watershed moment for the field. Maybe not even for the reasons that people immediately think. I think the biggest thing that happened from that, I would say, was that Google bought Boston Dynamics at the end of that. And then all the other tech giants looked around and said, wait a second, maybe I need to be doing this too. And there was a wave of investment that followed the DARPA Robotics Challenge that really did, I think, just bring a lot of more energy and resources into the community.
Most robotics demos never ship. Deployed is about the ones that do. This is Deployed, where physical AI gets real. I am so excited for this conversation, Russ. So jumping straight to intros, Russ Tedrake, professor at MIT, world famous roboticist, deep research in manipulation and locomotion and humanoids, and longtime researcher at TRI, and then recently founded Walden Robotics as CEO. And so I think we're a little bit getting the scoop here, right? In that maybe the deepest, at least, discussion we've had about Walden and what you guys are doing, because you just came out of stealth. So yeah. I'm super excited to have you. I think I had Sri Vasa on recently, and we talked a lot about kind of DARPA Humanoid Grand Challenge. And so you also were a leader in that. And obviously, the DARPA Grand Challenge, it really kicked off a lot of the work in self-driving. So I just wanted to dive in first to maybe give us some color on your experience with that Humanoid Grand Challenge. And if that ties to now at all, that's interesting. And if not, I'm curious, what you did take away from that.
Awesome. Well, thanks for having me, Brad. It's great to see you again. Excited to do it. So my particular journey on that, of course, we were doing humanoids. I was using the Boston Dynamics Atlas robot on the MIT team. It was a formative experience for me, for sure, partly just taking a very complex system to a higher level of maturity than I'd ever had to do before, with a team of very smart, student and postdoc researchers. And so we learned a ton in that. It was the first time ever, I had been working on legged robots. It was the first time ever that I could go to a meeting and talk to Jerry Pratt or Chris Atkinson, and we had the same robot and we could compare notes. That was the very first time my friends had the same robot as me, and we learned things together. Because legged robots were always one-offs before that. So that was really amazing. And then a lot of the folks on my team ended up going on and did stuff at Boston Dynamics, for instance, and that's just been amazing to see what they were able to do with more energy and resources and ideas behind that sort of technology. So hugely impactful experience for me. I mean, maybe even just the way I was perceived in the world. I think there were some people that thought I was a theory guy, and that's not wrong. I mean, a theorist wouldn't call me a theory guy, but that was maybe a time when I showed the world that we knew how to make real stuff work. And so that was sort of important in my evolution also.
Yeah, I was listening to the DoorDash founders recently talk about, all the challenges of putting actual robots, in the field and the street. Oh, if they drive along the sidewalk or along the side of the road and there's wet leaves on one side and dry road on the other, the motor controls have to adjust, right? Are there stories like that, kind of examples that you remember from that grand challenge?
For sure. I'll tell you, one of the ones that I think Jerry's team from IHMC was the first one to really nail, but he helped share it across. But we knew that the kinematics were funky when the leg was loaded. And it turns out the upper leg, I mean, Atlas was a big, heavy robot. It was 400 pounds loaded with batteries. The leg was actually deforming, the solid metal leg was deforming. If you put a high-speed camera on it and you watched the motion amplification, this leg was just, torquing under the stress, to the point where if you wanted to do accurate kinematics for foot placement and other things, you had to model it. And wow, how did I have to go to that level of detail to just put my foot down where I wanted to put my foot down? So, but that was one of a thousand. Like we learned a bunch about that whole sensor package. We certainly learned a lot about hands and how they broke. I remember in the DARPA Robotics trials, we used a hand. I won't name the hand, but we used a hand that I was pretty excited about. One of the tasks was clearing debris. It was just balsa wood 2x4s. It looked really heavy, but and you had to clear them away from the door and then go through the door. And I remember we picked up a balsa wood 2x4. The cable snapped on the hand, and wouldn't you know, we had to do the rest of the trial. Like we had to go through doors, we had to turn valves, we had to hold the 2x4 the whole time because I could not open the hand. And I'm like, I'm never using that hand again. That was super awkward. But yeah, cables are tough. They have a failure mode.
Well, I'm laughing because actually one of the things we're working on right now, reworking part of the gripper design for grabbing handlebar of carts, is because there is a state in which it gets locked. Right. Yeah. And then you can't unlock it. Right. And then you're just stuck to this cart.
You're just carrying a 2x4 around,
Yeah.
Like,
I mean, there was
gotten stuck with a nice small object, but no, this is like a 8-foot 2x4.
There was a video recently of I don't know if you saw this one, of two humanoids like in some fighting cage, and one of them's like head gets knocked off and is dangling, and like the robot's still moving around. When you watch all these videos now, right? Obviously the entertainment value of kung fu humanoids and is pretty interesting. And obviously like what they're being able to do from a kind of whole body locomotion standpoint is pretty incredible. But what do you see? Like how do you think about that? Like,
I think it is amazing. There was last night's funny video was a robot jumping out of a minivan. So,
do you think that one was real? I wasn't convinced that was not just AI these days. It's very hard to tell.
It's hard to know. It's hard to know. But it could have been real. And the fact that it could have been real is amazing, right? And there is a pipeline for locomotion that works incredibly well. It is almost formulaic now. That's a dream come true, I think, for a lot of us. And the hardware is strong enough to do incredible things. So, that same hardware isn't doing everything we want it to do. So I do, when I see all the entertainment applications, you kind of wonder, aren't there higher value things you could be doing with that robot? And maybe it sort of, you ask what it's not doing if it's spending the time doing that. But it's clearly on a rocket ship path to like better hardware at cost, at scale, that is, I think, super exciting.
Yeah, and yet, as you point out, there's so many like edge cases in the real world, right? Like I'd say this, like the real world is the ultimate eval for robots, right? Because I see a video recently. There's a humanoid pulling a cart now, and we pulled hundreds of 100,000 or more carts. The problem actually is not pulling the cart. The problem is, hey, if the casters aren't lined up, right? How do you get the casters to line up? But even worse, like how do you stop a 1,000-pound cart, right? Like it turns out stopping a 1,000-pound cart, the momentum will happily roll over your nice robot, right? And so there's so much in the real world that's and I know we've talked about this for years because helping and advising some of the work we were doing at Amazon, obviously, what you were doing at TRI, like you as much as, yes, your papers are deep in the theory and kind of key point work and things that to really kind of figure out how we generalize in these spaces. And yet it's all been like, hey, how do we get this stuff into the real world? So let me, I want to sprinkle Walden in a few times here, but tell us more, right? Like give us the quick pitch.
Okay. So I have been doing things in the lab for a long time, especially the manipulation. I mean, the diffusion policy work that started in 2022, and then we scaled that. We did some of the scaling law work around that. I really worked hard to convince myself that that was real, but you just watch that get better and better and better. And for me, it's now I have no interest in doing it in the lab anymore. I want to do it in the real world. And so the company Walden is spun out of TRI, but we've hired an incredible group of people to join us to complement our, sort of our research chops with real product chops and business chops. It's super focused on deploying. So deploy fast. The next great lessons will be learned in the field, listening to customers, closing the gap between what I do believe is a disruptive technology, but what I think you also have to appreciate that there's amazing wisdom in how people do manufacturing today. So we're focused on manufacturing first. And the best possible outcome would be to take the wisdom from manufacturing, take the disruptive technology that's coming out of AI, and do something better together than you could have done with either one independently. So yeah, super focused on deployment. We have Toyota as a big strategic partner, but we've also added Boeing and Samsung and a number of other real core strategics. We're already in production. So we started the company in January. Within 2 months, we were operating real 8-hour shifts in production in a Toyota factory. And here we go, off to the races.
We met in your offices, I don't know, 3 or 4 months ago.
Oh, I wanted to tell you more. That was like right before I could talk about it.
I know, and we had a bit of a it was an unfair debate because I hadn't seen what robot you were working on, but we had a bit of a debate about humanoids, non-humanoids. What's fascinating, right, is even just in 3 or 4 months since we had that debate in your office. We released our Gen 2
right.
And showed that at Automate, which brings, dexterous arms. And we just did some simple things made the screen a little taller so the eyes are a little higher. But the definition of what's a humanoid has just now widened, right? In other words, Proxy Gen 2 is now, considered a humanoid, right? And I'm like, that's fine. I'm a pragmatist about what can actually do real work in the world. But is that what you obviously Atlas was a human looking robot, right? Walden has elements of humans, but then elements of pragmatic, manufacturing. How do you think about, biomimicry, matter? Where do you come down on this?
Okay, love it. Let's have it. So, and I want you to push back. So, you see that we're splitting the difference here. So we've got a wheeled base, we've got simple grippers. So there's a lot of pragmatism there. This robot needs to work in factories today. It needs to do real hard work with its hands. I do have a more humanoid upper body, and there's good reasons for that, I think. So one of them, and you've had several guests that we've talked about this, but many of the points I agree with, including the counter arguments. But okay, fundamentally, the new disruptive technology is a more general purpose capability. So you do want a robot that is capable of doing a large set of tasks, right? So you want the opportunity to be big, the addressable market to be big. I do think you want to be mobile. I think the cobots that you see, the single arm cobots that you see in manufacturing lines, they're often low duty cycle. You're waiting for the work to come to the cobot. The mapping from people to tasks is often that one person is doing a task and then doing another task and moving around.
Right.
I think there's several reasons to want to be mobile. I don't think you need legs, even though I've worked on them for a long time and I love them and I will embrace them as soon as it makes sense. But the reason to not do legs yet is because the factories aren't ready for them. It's not the safety cases, the accepted requirements are not ready for them yet. I think you guys, all the AMRs that came before, have paved the way with requirements that are already accepted in factories around the world that we can follow on with a mobile manipulator that we can't use with a legged robot. For a fundamental reason. I mean, those safety cases are designed, with once you, I mean, you know this well, but once you're within a distance, you basically come to rest. You slow down proportional to the distance, and then you come to rest. A dynamically balancing biped might have to take steps to come to rest, which means, we are going from a 2-meter radius safety zone to like something dramatically bigger, to the point where it just makes more sense to put it behind a fence. And until that has been overcome, I just think that it's so much faster to get into the factories with a wheeled base.
Well,
we can talk about yes, humanoid if you want to, but.
Well, and I think to that point, it wasn't even that AMRs paved the way. It's just that manufacturing operators paved the floor, right? Actually, I don't.
There's two types of people. I feel like when I have conversations with folks, there's two types of customers, I think. Some people say like the floors are absolutely flat. If there was anything that would like slow down your wheels, it would be considered a tripping hazard. It would be immediately removed. Like you're not going to find anything like that. It's fine. And I've heard other people say, I'm renting the building. It's been holes drilled in it for 15 years. There's cracks. There's whatever. So you need to actually, but still wheels are fine. But like you need to be able to go over like.
But slightly bigger wheels, maybe. Yeah. In fact, Gen 2 for us adds a passive suspension element because. Just coming in and out of an elevator, for instance, there can be a gap but you're right. Not every floor is pristine, right? And sometimes I see these videos of like, a car carrier AMR that goes under, but it's got like a 0.5 millimeter clearance, right? And it's like, okay, that's a very. Actually, you did some work with us at Amazon, so you may remember this, but we actually innovated in how to pour flat concrete floors.
Oh, that's cool. Yeah.
Because, the pods, right, that the Amazon Hercules drive, the kind of Kiva successor, carries, if there's any waviness to the floor. And the reality is, if you 3D scan most concrete floors, they are not perfectly flat.
Right.
And so that waviness induces, and if you have a tall pod, induces some sway in the pod, right? And in order to make sure the two pods crossing each other don't hit each other, you need some amount of clearance between those two pods in order to, and so. So the flatter the floor, the tighter Amazon could keep the.
There you go. I also remember a story during that time where you guys were that every once in a while you'd install a robot and it would like the cement wouldn't take and it would be like just a little bit off angle and it's just like leave it, keep going to the next one. We're moving so fast that we're building out new deployments faster than we're like going to go back and fix something. So. You guys were scaling super fast, which is pretty.
Well, not everyone pours concrete the same way, and there were buildings where the concrete wasn't good, and then robots running over the same path, particularly carrying a heavy load, can wear the floor, right? And if it's not a floor kind of done to spec, all kinds of like real world challenges that don't come up in the lab, and so. I
remember even Raf, from the Kiva days was telling me that, he needed adaptive control because the wheels would wear and they were constantly adapting to the wheel wear in order to sort of put the miles that they were putting on those mobile robots. So yeah, it's good stuff. Real world stuff.
It's reminding me of some research. I don't know if it was your lab or an adjacent lab. I remember some MIT research just on like, could flying, planes and things handle damage, right? Could they continue flying if a wing part?
I remember it.
Yeah, that was some interesting. But that ties into like the AI space, right? Because I think we as humans use tools like we can adapt fairly quickly. Like if if I break a finger and I have to like tape it for a little bit, like I can still open doors and things like that. But there's this kind of school of thought in AI that, hey, if we're going to transfer from video or from other things, like the closest proximity to the biology is going to transfer the easiest. And yet, as I said, we're incredibly adaptable in that, you can tie an arm behind my back and do all, and I can still try to work my way out of, a locked door or things like that. So how do you think about, when you think about generality, right? Where do you think we are right now, right? Like, what are you excited about? But what are you looking for to show that we've really kind of unlocked physical AI in a significant way?
Well, so first of all, I think both of those things can be true. We are adapting to broken fingers and ski boots very quickly, but I still think it is true that you will transfer faster with lower amounts of data from data sets that are acquired from things that are more similar in morphology, right? So I think in the asymptote, we expect these models to just be very, very capable and be able to adjust very quickly. In the short term, you can have substantial realizable benefits by having an embodiment that's closer. And we are learning from humans. And it's also, when teleoperation is part of it, a human teleoperator can perform potentially better if they're operating through a familiar embodiment. And the other side of it, which is not to be forgotten, is that humans working alongside the robot you want the motion to be legible. They want it to move in a way that's sort of comfortable, expected. I think if it's moving like a human, then people feel more comfortable more quickly and can have a sort of their own internal mental models of the robot happen faster. So I think there are good reasons to do that kind of matching. I also think the field must be robust to this. The way that we're all getting training data is partly from collecting data on our own robots, but you also are bringing in data from massive other data sources, startups that are collecting data, simulation, all these other things, and you want to be able to put those into a melting pot and transfer the capabilities. So saying I'm going to have a model that works for exactly one embodiment, I've got this robot, this hand, whatever, that's not a winning strategy because you really want to be able to leverage all that diverse data. So I think we are somewhere in the middle. I think we can transfer those. We've seen it over and over again. It's just a little bit more expensive. I think every source of data, the closer it is to your embodiment, the less you need. So the more valuable it is in my mind. And you also have to be thoughtful, I think, about building bridges between different data sets. If you have a very different embodiment that you want to somehow do similar tasks, then maybe you have, your robot do the same tasks. And so it sort of helps the internal representations do some connectivity. There's a black magic, or let's say trade secret kind of, earned understanding of how those things work.
We debate this in our own, I have my own foundation model, physical AI team, and it's so hard because, sitting at Scale AI and watching self-driving, we poured a lot of data in and then it gets models better, but then a lot of it ends up being filtering out the data that's actually driving your model in the wrong direction, right? And so, the cross embodiment stuff, the research seems quite compelling. And at the same time, I think this is my soapbox on this, which I think the understanding what's really salient. I think in text, there's a huge amount of raw salience, word by word. And I think when we feed this kind of multi-sensor or just rich pixel data, what's actually salient. And obviously this is what the attention models are meant to help do, is to focus what's actually salient here, but it has to be in the data too, right? And so, it's if you were to compress a page of text and a page of numbers, right? At the bit level, there'll be some patterns, right? But at the character level, there won't really be, right? And I think, that's something we're thinking about a lot, which is, when we're feeding, if you feed one vertical task and another vertical task and there's not a lot of overlap, right? Then, I think about the utensil drawer in a kitchen. I think there's a huge amount of actual salient overlap between using those different utensils, where just like exploring in a kitchen and how to move the chairs and things, moving the chairs versus opening the refrigerator may not be as much intersection as like a spoon versus a spatula. And so I don't know, these are the debates and discussion we have, is how is additional data sources are cross embodiment, are they actually just they add diversity, which is great initially, but then are they adding outliers that your model is trying to fit, and ultimately, letting you get to 80%, but not to 98%?
For sure, there's a storied history in the recent years of machine learning where the data filtering was a huge part of the success, right? And but I also think we're getting, as we're getting more sophisticated, we're getting more and more models that can, or techniques, let's say, where you can deal with noisy data. We had a paper that was published recently by my student Adam, who explored one new mechanism for sort of learning from noisy data, and recognizing that when you're doing denoising diffusion models, that different levels of the noise hierarchy are doing different things, and you could actually, data that might be sort of corrupt in a small motion sense, but okay at the task sense, maybe you train just part of your denoising model on that. And then vice versa, if you have things where the total task might be incorrect or noisy in some way, but the fine manipulation details are valuable, then you can train a different part of your noising stack. And physical intelligence has an approach to conditioning on the data quality. There's a bunch of ideas that are coming into the space now of like, how do you more automatically process that whole data, as opposed to what we're doing, what most of us are doing today, is you take your data, you mark a bunch of it as scrap, right? And then the actual data that goes into your model is a small fraction of the data you actually spent money collecting.
Been also thinking a lot about this topic of kind of evals in the robotics space, right? And we didn't really use the term eval, but if you look at the Amazon picking challenge, right, that was one of the first publicly benchmarked kind of eval for how is a robotic policy actually doing. I actually don't know the history whether you guys competed in the picking challenge or not. I know you've done a lot
Alberto was the team MIT. Alberto Rodriguez led MIT's team. So I was cheering him on, but he was the lead for that.
I mean, to your point about these challenges have, I think, done incredible amount to not just motivate researchers and let people benchmark and understand where they're at, but also to bring students and grad students into that, and then for them to go out and raise funding and bring venture dollars into that. For instance,
on Alberto's team was Andy Zhang, super successful. Maybe I don't know how much robotics he was doing before that. Sharon Song also was on that team. She was doing more computer vision and perception before. And maybe we tilted her a little bit towards robotics with that example, but those have been huge wins for the field.
Well, I mean, I think there were at least a dozen manipulation startups where you could trace back their pedigree to someone was competing in that program, right? And look, Amazon's benefited greatly, not just in the folks it could hire, right, but also the acquisition of Covariant and just bringing great researchers into. But then I think what's fascinating is and then Jensen supercharged it by putting that graph with physical AI as forget that agentic thing. Let's just skip agentic altogether and focus on the hard problem. And I think, it did an amazing thing of bringing a lot of attention to this space.
I have learned through this process that there is a lot of capital that can flow through through our economy. I'm thrilled that it is flowing into stuff that I care about. It is only good from that perspective. I think, is it inefficient? Almost certainly. There's going to be lots and lots of money spent that doesn't go where we want it to go. But we have brought in so much talent, so much. I think we're going to see our supply chains evolve more quickly. We're going to see just the hardware more specifically evolve. We're going to see just crazy fast advances. So I do think that we're close enough that we're on escape velocity, and that the strongest companies will come out the other side. I wouldn't have started a company if I didn't believe that. But there will be a lot of waste in the short term. But even that is like amazingly good. I mean, let's put the money into something like this that could kind of advance the world.
I remember Greenspan, like in the .com days, saying we're just going to let it roll because the productivity is, and I think he kind of fueled a bubble there that did burst in kind of a painful way. This one feels different to me though, because the productivity gains for our society are going to be very real, right? Very real. If you think of productivity as the unit effort we put in versus the output we can achieve on the idea or the work, like, the effort is going to get substantially lower to do amazing things. And whether it's manufacture cars or airplanes, or whether it's, ensure that all the materials are there for a perfect, heart procedure in a hospital, whatever it happens to be, like those things are going to get so much easier if we really make this investment. Now, this may be, I'll admit, I don't even have my thoughts fully formed. Maybe by the time this podcast release, I'll have some more statement. But on the idea of the U.S. basically saying they're not going to approve foreign-built mobile robots, right? And interesting, like it looks like robotic arms aren't in that classification, but mobile robots like you and I are building.
For the record, that came in hours ago. So, and it's implications, I think, require legal scrutiny to understand exactly. I mean, I do think, the goal of really having extremely strong U.S. manufacturing base and whatever, that is incredibly good. The details matter, I think, and volatility doesn't really help anybody. So I think we have to just figure out what actually changed, unpack that, and go from there. But I do think that, I think it's important to invest in all possible ways in the manufacturing base in the country and globally.
Just to bring the means of production back closer to the distribution, right? Of
yes, where
that's being consumed is a net benefit, not just to global resilience, but just to actual carbon footprint and other things, yes, right? Just totally. Transportation is a huge cost to everything, and so
I remember there was a story I learned from a fisher in Boston. He says that people catch skate, a particular type of fish in Boston Harbor, freeze it, take it to Logan Airport, fly it to Asia, cut it up, freeze it, send it back to Boston Logan, and then we eat it in Boston restaurants. It's like, how can that be okay? So it just can't be okay.
I mean, at Amazon, we were deeply aware of how
sure.
much distribution, right? And I mean, I think one of Amazon's big savings in transportation costs in the last couple of years was to go to a more regional distribution network where things are being shipped more locally, right? And at the same time, to get the speed, they built an air hubs and air gateways, right? And started buying their own planes or leasing their own planes, right? So it's logistics. Logistics is this hidden engine that consumes a lot of fuel. So you were alluding to things maybe that you've learned in this, the capital is flowing through the economy. Are there other things as you've kind of the last year or so, I guess, or maybe since the beginning of the year where you've been putting together this new company? Are there other insights, tips for founders?
Okay, tips for founders. I mean, it's been super high growth time for me. I mean, I think I really like talking to other founders. A lot of them have stories about getting punched in the face and having to, or it's like eating a light bulb. I mean, everybody's got their own way to describe it, but I don't think it's an easy path to be the next great company. I mean, talking to investors, I've learned to think about this problem that I love of robotics in a much more macro, business way, and that has really, shed new light on this the love of my life in some sense. Not one of the loves. I have a beautiful family that I love very much. No, it's been super high growth. The other thing, I've really been spending a lot more time in the factories, and have found some people there that really, understand in a very, very deep way what is working, what is not working, what are the big opportunities for changing manufacturing. And they're not the ones that you read in the paper often. I think there's a lot of lessons there. And I don't think, the adage of Chesterton's fence, right? So that there's this,
tell the audience, yeah.
There's a story of I think a town mayor who, the town wants to remove a fence on a road, and the town mayor comes and they basically say, we want to remove this fence. He says, well, do you know why the fence is there? And they say, no, we don't know why it's there. They say, well, then I'm definitely not going to let you remove it. That's not good. And so I think to come in and say, we've got this great technology in robotics, and we're going to change the way people do manufacturing, because I see this inefficiency here. I think the reality of why things work as well as they do at a place like Toyota, for instance, is very subtle. The experts deeply understand it. And I don't think you just throw technology over the wall without understanding first what's good, what's still hard about what's happening right now. So I've been learning a ton, just really spending time on trying to deepen my understanding about production systems and manufacturing at scale and other things. And that's been a joy. I'm really enjoying that.
Yeah, and it's fascinating when you walk into different facilities how much diversity there is, right?
It's not just diversity; it's dynamicism, right? I think I had a vision of maybe the factory's kind of set in a certain way. I've heard people say everything's designed to reduce uncertainty and whatever. But my experience has been, I remember the first time I took a tour of a major plant, the person who was giving me the tour on a Monday morning was like, expert. He'd worked in that plant for 12 years. He's like, got a little lost. And I'm like, how can you possibly, he says, well, this line was over there yesterday on Friday, the plant just moves and grows and changes constantly. And it will evolve around the robots, right? There's no question. I think the brownfield deployment is real. That's awesome. That is enabling. But you don't have to just put robots in and do exactly what they're doing today. I think the factories will co-evolve very quickly with the robots as we design them. And thinking that through is really, really interesting to me.
No, that was, I think, both the fascinating lesson and the fascinating opportunity at Amazon, right? Because, I think people, they do the ROI calculation based on the robot and the work that it's doing, and that's all appropriate. What we always maybe failed to account for was when you move from a human process to a digital process with a robot, you now move it under software control. And so there were two additional flywheels, right? So one is the robot itself does something reliably and predictably. And I think people sometimes underestimate in an automotive plant that there is a metronome, right? That line is a metronome, and that keeps coordinated activities moving on a schedule. And we think of this with the trains, right? When the trains came in, towns and cities and things started to move on a schedule. Well, when you bring robots in that do things reliably, consistently, predictably, it adds a metronome to the process. So that adds some benefit, and that adds some predictability, that adds some reduction in entropy, right? But now that metronome is under software control. And so you can tweak it, you can change it, you can optimize it, you can run it faster in this part of the day or move it. And so we always got a compounding benefit. The first couple of years after a new robotic system was in, adjusting it, adapting it, figuring out, this idea of remapping the destinations in a sort center. If you have humans who are doing sortation of parcels to pallets to go to a certain zip code, you don't want to change the zip code of that pallet location because they burned that in their memory for the last, 6 months, and you change that destination. But if you change that destination for a robot, it's all under software control. It gets it right every single time, right? And so But then the second compounding thing was when you started to realize, okay, the next increment of benefit comes where we design the facility around the capability that we now have. Amazon is just so incredibly impressive in this because not only have they automated a substantial amount of it, but now they've software optimized a lot of it, and now they've built building designs that exploit it. And I'm sure they're now ahead in bringing AI at the like systems level to further optimize that, right? And I mean, Amazon was already doing that at a supply chain level with hands off the wheel buying, but I'm sure that's now being applied at the kind of systems optimization level. I think people don't fully realize, like, just they think of as we pitch customers and talk to them, they think of a robotics transformation as, eliminating this dirty, dangerous, dusty work, right? Difficult, whatever the multiple D's you want to use are. They just think of that. They don't always realize the compounding benefit. And that compounding benefit really advantages people who can move fast. If you spend the next 5 years deploying, that's a lot of friction, right? If you can get all that deployment to happen in 24, 36 months and then be optimized and then be designing, you're just now 4 years ahead of your competition, right? And I think that's, I don't know, I'm trying to figure out how to get that. There's just so few people who've gone through those phases of the journey to understand the downstream optimization that becomes possible, and the compounding benefit that we're going to see as a society, but that the enterprises which adopt this technology fastest are going to see massive, massive benefit.
Completely agree. I think a lot of the things you just said are top of mind here. And yeah, I do think this is one of the most important possible tools to unlock the sort of AI-enabled factory that everybody's talking about, the next wave of factory automation. So the role is much, much bigger than doing the jobs that people are doing right now. And I think there's, I like the future where the people are still very much involved in this, in sort of production, because I think people do bring, I would love to see the same way that our top software engineers using Claude Code or your favorite model, become able to write code even faster. I think the production engineers and the factory workers should be able to improve the line like dramatically faster. And then the other side of that, which is super interesting actually, is people who aren't programmers can vibe code almost anything now. So what does that look like for manufacturing? Maybe anybody can vibe code a small manufacturing company, right? Maybe you have an idea for a startup that requires manufacturing some good that never existed right now, and you could vibe code that. And so I think the productivity and the creativity that could become possible if we build these tools is really super exciting.
Often those folks on the factory floor have incredibly insightful ideas about how to make it more efficient. And yet the lag, right? The lag of bringing this automation in, or, bending this sheet metal or updating this software has kind of undermined a little bit the trust that they can actually affect change, right? But as that loop tightens, right, with vibe coding, with robots, with where an idea that someone on the floor has can get implemented, tomorrow, maybe next week, but not like next year. I think that's going to just build a lot of trust between us as technologists and operators, right?
That's right.
The trust between technologists and operators, I think, gets higher as changes can move quicker, right? And I think that's one of the most exciting things about vibe coding and in the operational world is we're going to be able to deliver solutions to people very quickly. And I think that's going to build more trust that this technology can really work.
I do think, lots of people talk about the Toyota production system in lots of different ways. And, there's versions of that where people say it's all about variability and leveling the work in process and all these other things. But one of the things I've increasingly come to understand is that it's actually about the people more than anything. At least this is today's level of understanding, right? Is that, I think some of the things that are most successful about TPS is actually that the work is spelled out clearly enough that people are informed, empowered to understand not only how to do the job, but also to understand what quality looks like in the job, and then empowered to be able to make changes quickly on the line. It's called Kaizen. And they actually, there's a whole culture of karakuri, which is like making clever devices in order to sort of improve the workflow on the job. And of course, production engineering is incredibly effective. And I think that fast and empowered sense of like, I can make this better and I know what better looks like is really, really core to what makes Toyota specifically an incredible manufacturing company. So, I think connecting to that, understanding that, seeing how robots can amplify that is really a huge opportunity.
As we're starting to wrap this conversation, I had David Mindell on a few weeks ago. He talked a lot about kind of MIT and the bridge from the building to the real world, and that. I'm curious, just I got back to MIT not too long ago. I got to speak in front of the 2007 robotics class. I think that's where we caught up. But and the energy on campus seemed as like creative as always. But you live it every day. Like what's your sense of kind of the vibe at MIT right now with technology transforming so quickly?
Well, it's an interesting time to be a student, for sure, with AI coming into every aspect of our lives. It's an interesting time to be an educator with all this transforming. Like the problem sets I wrote last year are solvable with a few tokens. Along with the challenges are just incredible opportunities. And so for people to just be able to embrace that, push that forefront, realize that this is a moment where if you really dive in deeply, you can change the world, is incredibly empowering. And I do think, MIT has absolutely been a joy for me to be able to interact with just incredibly talented people who are incredibly driven. And you put that set of people with this set of opportunities and just amazing things happen. So it's an incredible thing to be around.
Amazing. Thank you so much for the conversation today, Russ. Congratulations on Walden. I'm excited to, be working together to transform American enterprise. Yes, and bring it into the real world. And I obviously believe deeply in the deployment thesis and focus you have. We probably have our debates on the which robot's better in which ways, but I think we'll learn those things in the real world as we harden the robots. And so
let's do it.
Yeah, thank you so much.
Okay.